Hey there everyone, I welcome all of you to this another video of our pandas playlist. So in the first video, I introduced you to the pandas library, and here today in this video, we are going to talk about pandas series and data frames, which are essentially the core data structures that the pandas provides us with. Okay. Now, the objective of our today's video would be to learn how to create series and data frame objects. So we will be creating series and data frame from various methods like from dictionaries, from lists, and from other sequences. Then we will see how to access the data from these series and data frame, and we call it indexing and slicing the data from series and data frame. So these are the major objective of our today's video. Let us start now. So we will first talk about pandas series. Now series are actually a 1D array like object that can have named indexes. So in Python, if you are familiar with list, something like this, we have, say for example, 1, 2, 3, 4. So this is a list and this is 1D array. Okay. We can also create a numpy array that is similar to this list, numpy arrays. Okay. We have a range method that creates a similar one-dimensional sequence. All right. We have tuples like that. So these are all 1D array objects. Okay. Now series is also something very similar to this. The major difference here is that series have named indexes. That means we can access the data in series using their labels. For example, imagine something like a column. Okay, where we have the index and the data. So say for example, this is index and this is our data. For example, in index we have A, B, C, D, E, and in the data we have the values say 10, 20, 30, 40, 50, like that. So a series looks something like this. Now let us see the core components of our pandas series. Now the image that you see here is actually a pandas series that I have created, and I took the picture and I have pasted it here. So you can see right here is a pandas series. Now there are three core components in our pandas series. First is the data, which are the actual values stored in our series. What you see here is actually the data. Okay, let me change the color. I will take red one. So what you see here, this is called the data in our series. So this is the data. And what you see here on the left side are called index. So data are the actual values that are stored in our series, and using index, so this is the second core component, which is index. These are the labels that are used to efficiently locate, align, and manipulate the data. So this is index, and we use this index to access this data, these data. Okay. So by default, if we don't set these index, it starts from 0 and goes up to, for example, 0, 1, 2, 3, 4, 5. There are total 6 entries in our series. And what you see here, down here, the D type int 64, this is the data type of our data. You can see we have all the integers. So the D type of this series object is integer. So this is the third core component of our pandas series. Now, you may feel that this series is very similar to another type of built-in data structure in Python, and that is dictionaries. If you have seen dictionaries, then series and Python dictionaries look very similar. Now, here are the major differences between the series object and the Python dictionaries. Now, dictionaries, if you know in Python, they have key value pairs like this. You have key and you have some value associated with them. You can have many such key value pairs, and you access the data, that is these values, using the key in the dictionaries. Okay, so series also works something like this. I showed you, we access these data using the index values. Now the major difference here between the dictionary and series are that on series we can do math operations that that are compiled in C code, and they are extremely fast than dictionaries, because in dictionaries we will have to loop through the whole dictionary to do some operation, not just math operation, any operation on the values we have to do using manual loops in dictionaries. But with series this is not the case, because this is something called as vectorization feature that we get in series that does fast operations. Also, the data that is stored in series are very efficiently stored using numpy arrays. Okay, We will soon see in the code that the values in series are actually numpy arrays. And we also get many other helpful features of series like automatic data alignment, and we have some built-in statistical methods, and we have more advanced slicing and filtering to do more sophisticated access of data. All right, so these are the huge differences between a simple dictionary and pandas series. All right, now let us see how we can actually create pandas series. So first we are going to see how to create pandas series using 1D sequences like list or a 1D numpy array or range sequence or a tuple. So these are all 1D sequences, 1D sequences, and we will be using this method called pd.series to create this series. So we can pass any of this, a list or a numpy array or a range or a tuple or any other 1D sequence that you know, we can pass in this block here, and we will get this series. So let me go to my notebook now, and first we will import the pandas module, import pandas as pd. So this is where we will get the series object. So you can see here I have already created a list. So this is the list that will be our data in our series that we are going to create now, and this is the list that will be the index values. So I will use pd dot, and in capital S I will write series, and inside these I will provide my data. So which is right now a list that I have created here, and I will run this. Okay, data list. Okay, so I will have to run this first. So we get our pandas series. So you can see here that these are our data values, and you can see that pandas has automatically created an integer based indexing that starts from 0. Okay, and if we want our own index labels, that is what we want to do here, that we want to create this type of series. You can see that indexes are actually these fruit names: apple, orange, mango, watermelon. So in that case we can pass a second argument, that is index is equals to, and we will pass this index list. So we have just named it index. All right, now if we run this, so that index list becomes our label index of this series, and this data list are the data values. So in the first argument we pass the data, and the second argument we pass the labels that we want as index. Note that if I add another data, say 80, and now I run this, it gives me an error. It says that the length of values is 7 and it does not match the length of index. It happened here because the length of the data here, there are actually 7 elements here in our data list, while in index we only have 6 values. So make sure that the length of your data in index must match, or else if you just don't want to give any index, by default the Python will create this integer index which starts from 0. Okay, so for now we are creating that index, and let us store this into a variable name s, and we will like to print this. Okay, we have to remove this. So fine, we have created our first pandas series. Now let us try to create our pandas series from another very popular method, that is from the dictionaries. Now we will use the same method pd.series, but this time here we will provide a pandas dictionary. Now Python dictionary has key value pairs, you know that. So key colon value pairs, many such key value pairs. Okay, so the idea here is that the keys of the dictionary, which is A, B, C, so these key of the dictionaries will become our label indexes, and the values associated with them will become their corresponding values in our series. Okay, so very simple to create using dictionary. Let us try to code that. So here I have created already a dictionary. You can see there are 3 keys A, B, C and corresponding values associated to them. Let us run this, and I will use that same method pd.series, and I will pass this data dictionary. So the keys becomes the label index, and their corresponding values become our values in the series. Now as we have created a series using 2 different ways, that is using this list and a dictionary, let us also see some attributes related to the series. So I showed you here that series actually has 3 core components: data, index, and the data type of our values. So let us store this series in our variable s, and I will want to print this. So this is our series. And if I want to access the index of these series, I will write s dot index. So these are the index of our series. If I want the values, I would write s dot values. So these are actually the numpy arrays, as I already told you before. Okay, so we have index, values, and also we want to print the data type of our values. We know that it's integer, it is already showing here, but we can also access it using the dtype attribute. So s dot dtype, and it is integer. We can also check the length of this series using len s. That also we can do, and one more way we can check using s dot shape. So like in numpy array, we have this method, we have in series also. By the way, this is more used with the data frame, but it works with series also. So you can check the size of your series using these two methods. Okay, if we want to convert this integers into some other values, say float, we can do that using s dot as type. Just like in numpy, we also had this as type method, and we can provide here the data type in which we want to convert our series. So I will write, say for example, float 32. So this will create an entirely new series in which we have our data type changed. You can see they are now float values. Our series s will still be the same. Okay, so if you want this series, you can store it in some other variable. Fine. So we have created our series using dictionaries and list. Now we will want to access the data from the series, and we call it indexing and slicing the data in series. So we will use this dot loc. So for example, this is our series s. So to access, say for example, this first row, I will write s dot loc, and I will give in square bracket, I will say a, string a. So this shall give me this value 10. If I write s dot loc, I can also pass a list of the indexes. So for example, I write a, then c, then b. So any order I want to access, I can do that using s dot loc. So let us try to do that in code. We have the series s. So if I write s dot loc, square brackets, and the index. So I want to access a, capital A. So this is given as a string. So this will give me the scalar 10. If I want to pass multiple indexes, so here I will write, I will pass a list. So a, comma c, comma b. So I have created, I have accessed multiple values this time, and the order also has to be here the same. Okay, so this time it's a series, and when we accessed that just this a index, it was a scalar value. So it depends on what type of access you are performing. Okay, we can also use directly the square brackets and write that index label, but this is generally not recommended by me, because you will see further that in data frame also we use this type of accessing to actually access the columns in our data frame table. So you can also do this way also, okay, but I prefer using this dot location. Uh, One more way to access our data in series is using this dot I location. Now remember, I told you that when creating a series, pandas automatically creates this indexes. So pandas series will automatically create in its backend, it will create integer indexes that will start from 0. So the first row will be 0, second row will be 1, 2, and so on like that. So series already has its built-in index. We can access these using s dot I loc. So s dot I location, and inside the square brackets, just like what we did here, we can pass the integer index. So for example, I want to select the second row, I will pass s dot I location 1. If I want to access multiple rows, I will pass, say, 2, 1, 1 again. Let us try to do that in code. So I will write s dot I location 1. So this is our second value in our series. If I write s dot I location, and I will pass multiple such labels. So you can see like that. So this was about indexing. Now if we talk about slicing, we can pass the indexes in this way. Say for example, from b colon c. It tells me to select all the entries from column B, sorry, from index B to index C. Whatever there is between them, we have to select between that. So let us try to do that. I will write s dot loc from A to say B. I want to select, so it will select from A to B. We have, for now we don't have anything between them, so it will just select these two. We can also do that same thing with I location. We can provide, say, from 2 we want all the entries, so I will write s dot I location and 2 colon, so it will give me from 2, that is 0 1 2. So yeah, 0 1 and 2, so this last row we will get because this is at integer index 2. Fine. Now, as we have seen how to access the data in our series, we will also see now how to modify the pandas series. Now, just like we access the data in our series, we can modify using this equal to operator. Now, there are also many other ways to modify the data in series. We will be discussing that in later videos when we will be talking about specific things like cleaning and transformation, things like that. So for now, say for example, there is a series S and I want to change it. Let us take an example of series. So for example, here is a series and I want to change this second index, this, to 0. So I will write s dot I location 2 is equals to 0 simply. So this will modify the series in place. If I want to say change all the values to 0, so I will write s dot I location and colon. This is for selecting all the values and set it to 0. I can also pass a list, say for example s dot I location from 1. I want to select all the values and I will pass a list corresponding to each value that I want to fill. So I want to fill with, say, 4 comma 5. So like that also is possible. So let us try to modify the series here. I will write, so I'll print the series first. This is our series. I'll write s dot I location and I want to modify, say, the second value and I'll write it to 0 and I will print this series. So you can see this B has, the value for B has changed to 0. I can also use this labeled indexes using dot location. Dot location is for our labeled indexes that we passed it. So C, say for example, I want to say is equals to 100 and I will print the series S. So it has changed the value for C. We can also do, I showed you the list. So s dot, say, I location from 1 and I will pass this time a list. So I will say 4 comma 5 and I will print the series. So it has changed the value accordingly for B and C. Okay. So this is how the modification in series works. This was a very basic overview. We will be seeing more advanced way of modifying in further videos. So now we come to a very important data structure in whole pandas, that is data frames. So understanding data frame is very crucial. So a data frame is actually a two-dimensional tabular data structure with labeled rows and columns. So it looks something like a two-dimensional data structure, something like this. So these are the rows. So these are the rows and these are the columns. So we see something like in NumPy 2D arrays also, but this time it has, it says it has labeled rows and columns. So like in series, we had label names like A, B, C. Here we have labeled rows as well as labeled columns. So let me show you here. So pandas data frame has 3 core components. It has index, columns and the data. So index are used to locate the rows. So what you see here, right side here, you 0, 1, 2, these are the index, and the columns are used to locate each column. So here you see the names in bold, product, price, in stock. These are columns, index, columns, and the remaining part of this table is the data, actual data, or you can say values. Okay, so these are the actual values that are stored in our data structure. So a pandas data frame is composed of 3 core components: the index, the columns, and the data values. Now let us create our pandas data frame. First, we will try to create it using dictionary. So as you can see here, first I will show you here on the board and then we will move to the Jupyter notebook to implement this. So first I have created a variable data, which is a dictionary, and it has 3 keys: product, price, and in stock. They are all strings, and they are all strings, and these are the three keys. And for each of these keys I have list, and each of this list has three values in it. So this first list has these three strings: laptop, mouse, monitor. This second list has the price values, and this last list is actually having boolean values. So this is a dictionary of list, you can say. Okay, so the idea here is as so I will use this method called pd.DataFrame. So here D is capital and F is also capital, note that. And I will provide this dictionary over here in these parentheses. What I will get here in the output is a table where each key of that dictionary will become a column name, and the values that I provide to these respective keys will become the column values for the column names. Okay, so these are the list that I provided here in the dictionary. So let us try to code that. I've already created my data dictionary. You can see three keys that are product, price, and in stock. So these will become the column names, and the list that we provide to these keys will become the values for our column. So I will write pd dot capital D data and capital F frame, and I will provide this data dictionary. First I will have to run this. So I will provide this data dictionary, and I will run this. So here we have our pandas data frame. You can see automatically it has created these integer indexes, that is starting from 0. If we want to change this also, we can write. So I will first copy this. We can pass index is equals to, say I want to write 1 comma 2 comma 3. So we can change these indexes using this index attribute. Fine. Now we will see some attributes related to our data frame. First, I will want to store this data frame in our variable df is equals to this, and I will just want to print this df. So this will be our data frame. Let me delete this. So df dot index will give us the index range. Now since we have since these are only the default indexes, we didn't provide any index here, so it gives something like this object, that is range index. It starts from 0, stops at 3, and with a step value of 1. If I write df dot columns, I will get the column values in my data frame. So you can see we have product, price, and in stock. Okay, and if you write df dot values, we will get a 2D numpy array in which we can see here our rows as the list. You can see individual list. All right, so this is a 2D numpy array. So we have seen the three core components of our data frame: the index, columns, and values. We will see some more attributes like df dot shape. It tells us the shape of our data frame, that is it has 3 rows and 3 columns. That's it. If we write df dot d type, okay, it's an attribute, not a method. So df dot d type, I only have to write df dot info, I guess. Yeah. Now this is a very useful method, df dot info. It tells us a lot about our data frame. So first it tells us about the indexes, that is from 0 to 2. It tells us that our data frame has total 3 columns. Okay, and it lists the columns. So we have product, price, and in stock. These are the 3 columns, and it also tells us how many of them are non-nulls. So as you can see now, we have all the values filled, so there is no nan values inside it, so all of them are non-nulls, and the data type of the data in that column. So you can see that in first column we have strings, in second column we have integers, and in third columns we have boolean values. So for first column we get object. Now object is denoted for any mixed data type, whether it is string or integers. If we have mixed data type, then it will just say object. Okay, we can change that. We'll see later how to change all that data type. Okay, so in price we have integers, so it says int64, and in the last column we have boolean values. Okay, it also tells us what is the amount of memory that it takes on our laptop. Fine. So we have seen few attributes related to our data frame. We will see how to create a data frame from two-dimensional arrays. So it can be a list of list or a 2D numpy array. So here, for example, I have a 2D list, and you can see that after using pd.DataFrame, pd.DataFrame, I will pass this list inside this. After using this, you will see that each row in our series, in our data frame is actually an individual list in our nested list. So the first list will become first row of our data frame, second list will become the second row, third list will become the third row. So on like this. So each of these individual lists will become rows in our data frame. Okay, and you can see the column indexes and the integer indexes are by default initialized from 0, starting from 0. Okay, so let us try to create that. So I've created a 2D list. We can also do that using a 2D numpy array. Okay, so I will run this. Now I will write pd dot data frame, and I will pass this list. So here we have our data frame, and if we don't want these index or values, if we want our custom labels, I can write index is equals to say 1 comma 2 comma 3, and I can pass columns as a list also. So I write a comma b comma c. So you can see that both indexes and column values have been changed. All right. Now, as we saw in series, how we can access the data in series, here we are going to access the data from pandas data frames. So here also we use this dot location method, and inside the square brackets, we provide the row index. So this dot location is used to select rows by default. Okay, so I will show you first. If I use df dot location, and if I pass here 0, it will give me this first row in my data frame. This is the first row, so it will give me this first row. If I use this dot I location, then this should also work, because in this data frame we don't have our labeled indexes, our custom labeled indexes. So if we use any of those, it would work same. Okay, if we pass in this dot location, if we pass a list of indexes, like I showed you in series, that should also work like that. It will select this row 1 and row 2 like this. Okay, and we can also do that ranged based slicing. So if I say from 1 to 2, select all the rows, like that is also possible. So let us try to do that in our Jupyter notebook. I will want to print our data frame. So this is our data frame. If I write df dot location 1, so notice that I have selected only one row, and it will result in a series object. What you see here in the output is actually a series. Okay, and if I select, say for example, dot I location, so this will also work same, because we don't have set any indexes yet. And to set those indexes, we can also use df dot index directly here, or we can pass that index using this index attribute. We can pass our index list, we can also pass our columns list, or after creating the data frame, we can also change using these attributes that I showed you before. So df dot index is equals to 1 2 3. So now the data frame of our index have been changed. Let us try to print this. So this is our new data frame with updated indexes. I will write df dot location. This time I will pass this third value, and it will select this last row as a series. And for that series, the labels will be the column names, and the values will be the values in the rows itself. Fine. If I use df dot I location, now it will give me error, because the integer index only goes from 0, 1, and 2. So if I write 0, then it shall select this first row. Now this df dot location is only used to select the rows. For now, just remember that df dot location is only used to select the rows. And if we want to select the columns, we would directly write df and square brackets, and inside this we'll pass the column name. So for example, I want to select this price column, so I will write df square brackets, and in string I will write this column name, exactly that name, and I will close this. So this shall select this column price, and this will output me as a series. If I write df, I can select multiple column using this list. I can pass this list. Say I want to select price, then I want to select product, and I will close this list. So this time I will get a data frame, actually data frame. Okay, uh, I will write df and square brackets. So this is to select columns, and this dot location is used to select rows. We can select one row as a series, we can select multiple rows, okay, as a another data frame. Okay, okay, let me show you how to select the rows. df dot I location. So from 0 to 2 I want all the rows, so I will select this as a new data frame. All right, I can also pass multiple rows using df dot, say, I location 2 comma 2 comma 1. So that is also possible. All right, now we will select the columns. So df and directly square brackets, inside this I will pass the column name. If I want to access this price column, so I will write price, and what we see here in the output is a pandas series object. So data frame, you can actually think of it as a collection of many series. Okay, if I want to select, say, a list, I will write price. I want to select the price column and also the product column. So in the same order they will be selected as I am passing here in this list. So this type of passing the list is actually used to select multiple columns. And I will run this. So first I will get the price column, then I get the product column. Now we will see how to use this df dot location or dot I location to index across these rows and columns, both rows and columns. So in df dot location, first we will provide the row index, second we will provide the column index. So for example, I want to select these last two rows, okay, and in these last two rows I want to only select these first two columns. So this is the subset of data that I want to select from my data frame. So I will write df dot location, and I will pass the label index for the rows, that is from 1 I want all the rows, and in the next argument I will write the column index. So I can select one column, I can select multiple columns, or I can also select a range of column here. So for example, from product to price. So this statement will select all the rows from 1, and in the columns it will select all the columns from product to price. So let us try to see it here. I will write df dot location. So df dot location is generally used for selecting rows. I mean, by default it is used for selecting rows, but we can also index columns as well. So first I will select the rows, that is from 1, and then I will select product to price. So it will select like this. Whatever we have seen in row indexing and column indexing, we can use here. So I can pass just one row or one column or multiple rows or any multiple columns or something range like this. Or say, for example, if I give here multiple indexes, say 2 comma 2 comma 1. So this is also possible. Okay. Now, actually there are many ways to modify a data frame. We'll be seeing in further videos when we will see more advanced topic like data cleaning and data transformation. There are various methods to transform the data in our data frame, modify, clean, many other methods to change the data. Here I will be just discussing a simple equal to operator that you can use after indexing and slicing the data frame. You can just use this equal to operator to change the data. So say, for example, I want to change this price column. I will write df and I will select this price column, and I will specify new values for my price. So I can pass as a list, say, for example, say 500, 20, 300. So let us try to do that. So this is our data frame, and if I write df dot price, So this will select the price column as series, and I will write equal to, and I will provide the price values, that is 500, 20, 300, and let us print the data frame. So you can see that the prices have been changed. You can use here a list or a range or a tuple, but make sure that it is the same length as the number of rows in our data frame. You can also just change the whole column by passing the scalar value. If I write df dot price is equals to 0, so this will change all the values in that column to 0. Okay, that sub that selecting the subset of data frame that I showed you before, that also works the same way. If I select df dot I location, so I location is used for integer based indexing, both for rows as well as columns. So first I will provide the row index. I want to select say 0th and the first row, 0 and 1 row, and in the columns I want to select from price column, I want to select all the columns. So from price column I will select all the columns. So after price we have price and in stock, these are the two columns, and in the rows I have selected this 0th row and this first row. Okay, so because I have used dot I location, I have specified integer indexes. Now I will set them, say, to 2D list. I can provide it 2D list. So I will write 20 comma false, and I will write another list as, say, 100 comma false. And if I print that data frame, okay, it's a warning, you can ignore that. So you can see that we can modify values using this equal to operator, and just specify what we want to change. Okay, if we used a simple scalar value here, say I want to just set them to, say, 0, and if I print the df, you can see that all the values for this particular subset that we selected has been set to 0. So this was about modifying the data in our data frame. We can also change the indexes and columns. If I write df dot index, so these are the index values, I can simply change them using equal to, say, 10, 20, 30. And if I print the data frame, I will get this data frame with changed indexes. I can, same way I can change the column values as well. Okay. We can also add new rows and columns. I will show you here in the code. Say if I write df of, say, some new column name, and I will say 1, and if I print the data frame, you can see that this new column was not in our data frame, but I selected this column and set to 1. So that means I have added a new column. If I wish, I can pass it like a list, something like this. So we have added new column as well. We can add new rows like df dot location, say 100. So 100 name index is not here, we can see. So it will add a new row. I will pass, say, speaker, our new product. Its price will be 20. It is not in stock. And if I print the data frame, here we have our new row. So that's all for today's video. I hope you enjoyed this series and data frame video. I will see you in the next video. Till then, take care and keep learning.